Hi guys, today we're going to talk a little bit about internal and exterior angles of a polygon. So let me show you a little of what I mean. So if I have a triangle here, interior angles would be these three angles. Now the thing is, on a triangle, no matter what three angles that you have, it always has to total 180 when you're talking about the angles inside. So no matter what triangle you're looking at, if you have angle here 1, 2, and 3, when I add the measures of those angles together, they're always going to total 180 degrees. So let's expand on that and talk about what happens when I have something that's more than three-sided. So here's an example of one. This happens to be a square. And we know with the square, all of the corners that we have here are 90 degrees. So if I were to add them up, they total 360 degrees. Now with a quadrilateral, a four-sided figure, doesn't matter what kind of four-sided figure you have, they all have to total 360 at the end. Now here's a little bit of the reason why. So here's a square, and I want you to consider what happens if I draw a line here. So if I draw a line here, I have one triangle that's up here and a second triangle that's down here. So if each triangle is 180 degrees, then it's going to total 360 degrees altogether. Now the big thing is when you go through to do your shapes, your triangles, when you break it into as many triangles as you can, you want to be able to do it so that the angles are all on the outside. You don't want anything to overlap here in the middle, like another line that would go here, and you'd have a bunch of angles in the middle. You want them to all be out here. So I want you to realize the pattern. It's four-sided, and there are two triangles. Okay, so four-sided, and that breaks into two triangles. So let's see what else happens. So here's a pentagon, five-sided figure. So if I were looking at this one and trying to break it into triangles, oops, there would be one. Here would be another. So I have 1, 2, 3 triangles. So that means I have 180 degrees for each one of those. So if I put all of those together, that's going to make it 540. So that means that all of the angles inside are going to total 540. So it is five-sided, and it gives you three triangles. That means however many sided it is, it has two less triangles. That's kind of the pattern. So if I look at each one of these, they kind of have them set up. So if it is three-sided, it's going to be 160. Four-sided is 360. Five-sided is 540. Now, we just did that. So if it were six-sided, it's 720. It's the pattern that keeps going. And eventually, it's based on however many sides you have. If I subtract 2 and multiply by 180, that'll give me the total. Now, to know what the angles are inside, if it's a regular polygon, that means that all the sides are the same length, all the angles inside are equal. So if I took 180 and divided it by 3, I would get 60. That's each angle inside this triangle would have to be 60 degrees if it were a regular polygon. Okay, now with a quadrilateral, if it's 360 divided by 4, because there are 4 sides, it's going to be 90 degrees. That means that each of those would be 90 degrees. Pentagon, if it's a regular pentagon, 540 divided by 5 is going to be 108. So that means each of these angles would be 108 degrees. And it kind of keeps the pattern going all the way down. Now this would be something I'd probably for a second pause the screen and take a screenshot so you can kind of remember what those are. Okay, now this is the reason they use them. So if it's interior, this one has an angle measurement of 29, 105, and it wants to know what this third one is. So this one right here is missing, and I don't know what it is. So remember, they have to total 180. So if I subtract the two angles that I have, we can figure out what's left over. So if I subtract 105 and I subtract 29, I'm going to be left with 46 degrees. and that would be the missing angle. Now, if I think that's 46 and I'm not sure, I should be able to add all three of those back together and get 180. So that should be something that you can do automatically as you're looking at these. Okay, to kind of double check yourself. So if I look at this one happens to be, let's see, 1, 2, 3, 4. It's four-sided. So if it's four-sided, I know it's got a total 360. And they want to know this angle here that is missing. So I'm going to have to subtract 113. I'm going to have to subtract 51 and 82 to see what's left over. So 360 minus 113 minus 51 minus 82. And I'm left with 114. That would be this missing one. Okay, which would match this. Okay, let's look at the next one. So if I look at the next one, let's see, 1, 2, 3, 4, 5, 6-sided. So I know this is a 6-sided shape. So I'm going to go back up to my table for a minute. So if I look at 6-sided, it's going to be 720 altogether. So 720 total. I'm going to have to subtract 120, which would be this one, 160, 130, 110, and then realize that this angle right here is 90. So I'm going to have to subtract those and see what's left. So 720 minus 120 minus 160 minus 130 minus 110 minus 90. So I'm going to be left with 110 degrees. So that means this angle right here would be 110. Okay, so you kind of get the idea of how those angles work on the inside. Okay, so when they do exterior angles, this is the way it works. No matter what I have inside of here, if I want to find the external angle to this angle in particular, I pretend like there's a straight line. And we know that a straight line is going to total 180 degrees. So if I know that this interior angle is 30, that means this exterior one's 150. Now, no matter what shape you have, it's always continuing the line. And then you can do your 180 minus whatever this is to get your exterior. Now, there are a couple things that you need to know that when you're talking about polygons, the exterior angles always total 360 degrees. Okay, doesn't matter what kind of polygon it is. It can be a triangle, it can be a square, it can be anything. So this question says, what's the sum of the exterior angles of an octagon? It's still 360 degrees. It does not matter how many sides it has. That's going to be its total no matter what. So here is a decagon, which is a 10-sided figure. Wants to know the size of one of the exterior angles. So first of all, it is 10-sided, which means it has 10 exterior angles. So if I do 10, if I have 10-sided, oops, if I take 360 and divide it by 10, it's going to be 36. So it's 36 degrees for one angle. All of them are the same when they're talking about this because it's regular. Okay, this one says, what's the size of one exterior angle of a regular heptagon? So if it's heptagon, it's 7-sided, which means it has 7 angles. So 360 divided by 7, which is 51.4. So it's 51.4 degrees. Okay, we'll talk about a few more in just a minute.